Okay, so this lesson is on tangents, and the tangents are a part of your circle. We talked about the tangents of a circle when we did the parts of a circle lesson. Okay, so what you need to know about a tangent is that a tangent line and a radius are perpendicular. They create a 90-degree angle. So what that means is for this angle here, that's 90 degrees. This is your radius, and then this right here will be your tangent. This long line, we'll put a T for that. This long line here will be your tangent. Together, the radius and the tangent create a 90-degree angle. Tangent lines are, for theorem 2, tangent lines are congruent when met at an same exterior point. So if this is your exterior point and they meet at this point, they are congruent. Okay? So both lines will be the same measure. For theorem 3, it houses the same as theorem 2, but it's looking at a circle inscribed in a polygon, circumscribed polygons, where a circle is inside of the polygon. So you have all those exterior points, okay? And each one of those, and even with all of those exterior points, your they're congruent. So this one will be congruent to this one. This one is congruent to this one. This one will be congruent to this one. And this line will be congruent to this line. Okay? So though these are congruent, these will be congruent. These two lines will be congruent. And then these two lines will be congruent because they meet at that same exterior point. Okay? So let's talk about tangents and go over some of these problems. So we have, for example, the first one. It says line L is tangent to circle S if and only if line L is perpendicular to T. Okay? If line ST, sorry, is perpendicular to ST. Okay? So, because this is line L, because if this line here is perpendicular to the radius here, ST, then, I'm sorry, if it touches ST at that point of tangency T, then it is perpendicular, which creates that 90-degree angle. So, the measure of angle STX, okay, so the measure of that angle, STX, which is this angle here, will be 90 degrees. And the point of tangency is where the radius and, where the tangent line meets the circle, and the tangent line meets the circle at point T, which is right here. So your point of tangency is at T. All right, the next one talks about the two segments that we talked about before with the exterior point. Again, your exterior point is here. So if two segments from the same exterior point are tangent to a circle, then they are congruent. So if QP and RP are tangent to circle C, then they are congruent. Okay, then they are congruent. So that means that this line is congruent to this line. So you have QP is congruent to RP. Okay, so now we're going to use this diagram here, and we're going to use this to solve problems. All right, so if you want to mark on this diagram, it's up to you, but I'm going to be marking and erasing because I'm using it to do the 6 problems. So one theorem that I know for sure you're going to need to know when we're doing these problems is the Pythagorean theorem. Okay, Pythagorean theorem is a squared. You probably can't see that. I'm going to write it across over here. A squared plus b squared equals c squared. Okay? Make sure you write that down on your paper, Pythagorean theorem. Okay? You're going to need to know that for some of these problems. A squared plus b squared equals c squared. Okay? All right. So, start with question 1. It says find the measure of angle BCM. Okay? BCM. That's that measure of the angle there. We can find the measure of that angle because we know that this right here is a radius and then CM is your tangent. Okay, CM is your tangent, and we know it's a tangent because in the questions up here, the directions, it said MC and MZ are tangents to circle B. Okay, MC and MZ are tangents to circle B. So because we know they're tangents and we know that BC is a radius and CM right here is your tangent, we know that a radius and a tangent create a 90-degree angle because they are perpendicular. So your angle measure is 90 degrees. Number 2, find the length of CM if CM is 5x minus 9. Okay. We know that CM is 5. So this one is 5x minus 9. And we know that MZ is equal to x plus 7. So it says find the measure. What we know about both of these tangents is that they meet at that exterior point. Because they meet at the exterior point, they are congruent. So we can say that 5x minus 9 equals x plus 7. Okay? 5x minus 9 equals x plus 7. So we're going to solve this. Now you can do it in your Desmos or you can do it by hand. Okay? Whatever one is easier for you. Okay? So if I add, subtract x from both sides, this is going to give me 4x minus 9 equals 7. Okay? Then I need to add 7 to both sides. I'm sorry, subtract, add 9, not add 7. Add 9 to both sides. And when I add 9 to both sides, I get 4x equals 16. Okay? Divide by 4. X equals 4. Okay? And that's just the beginning because I only found x, but it told me to find CM. So now that I know x, I can find CM because CM is 5x minus 9. Okay? So what I do is I take that 4 and I'm going to plug it in into the equation for CM. Okay? So I'm going to do 5 times that 4 minus 9. 5 times 4 is 20. 20 minus 9 equals 11. So the answer to this one is 11. Okay? All right. So now I'm going to erase off the figure because we got to do question 3. Question 3 says, find the length of EM if CM is equal to 12. So we know CM here is 12. And it says find, and BC is 5. So BC here is 5. And I want to find, let's make this a little bit bigger so I can highlight. We want to find the length of EM. So EM is this piece right here. We want to find that piece. Now, what we know about a circle is that a circle can have multiple radii, meaning it can have multiple radiuses. So if BC is a radius and it's 5, BZ means it's going to be a radius, that's going to be 5, and BE is a radius, and that's going to be 5. We want to keep that in mind as we solve this problem, okay? Keep that in mind as we solve this problem. We want to find EM But in order for us to find EM, we need to find the whole side. Okay, we need to find that whole side. Okay? We need to find the whole thing. And we know that this creates a right triangle. Okay? So, we can use the Pythagorean theorem that I told you to keep in mind earlier. So, in keeping the Pythagorean theorem, we know that 12 squared plus 5 squared equals x squared. Because this side right here, we're going to call it x. Okay? Now, 12 squared is equal to 144. 5 squared is 25. And that equals x squared. Okay? 144 plus 25 is 169. So 169 equals x squared. We want to find x. So in order to find x, we take the square root of both sides. By taking the square root of both sides, we get 13 equals x. Okay? Now, 13 equals x, but we only want to know this portion right here, this yellow portion. We want to know what EM is equal to. So if the whole thing is 13, right? The whole thing is 13. We want to find that little portion. So the whole thing was 13. And we want to find the portion EM. But we remember that BE is also a radius. So we're going to do 13 minus 5. And 13 minus 5 is 8. Okay? So the answer to this one is 8. Okay? We got 8. Alright, let's delete. So we can do the next problem. And I'll just stick the answer in the box so that y'all can see it. Alright. Number 4. If the measure of angle CBM equals 60 degrees. Alright. So CBM. So this angle right here is 60 degrees. If CBM is 60 degrees, we want to view, and CM is 13 square roots of 3. Find the length of BC. Okay, we want to find the length of BC. So we are looking for, let me click my yellow. We are looking for this length here. Okay. Now, to find that length, we got to think about what we know about triangles. We talked about triangle trig earlier this week. Okay. And we talked about the sides of the triangles in reference to an angle. So if we're thinking about that, the sides of a triangle in reference to an angle, we can find what BC is equal to. Okay. So we know that this angle right here is 60 degrees. So that's my reference angle. And we're using my reference angle, and I'm looking for this side right here. So I have my opposite and I have my adjacent. So opposite and adjacent, thinking about this, we're going back to SOHCAHTOA. Okay. Opposite and adjacent. That's O and A. So O and A is tangent. So we're going to use the tangent of that. So we're going to say tangent of the angle, which is 60, equals 13 square roots of 3 over x. Okay, 13 square roots of 3 over x. Now, if you remember in the video that I gave you before, I gave you that little trick where you don't have to do all the math, just go back and forth and you can flip-flop those two. And if you do that, then that's going to equal 13 square roots of 3 over tangent 60. Okay? And if you place that in your calculator, your value of x is going to equal 13. Okay? So x equals 13. Now, let's talk about question 5. in question 6. Question 5 says that find the length of CM if BC is 12. So BC here is 12. And BM, the whole line, that whole line, BM is 20. Okay? The whole line is 20. It's asking you to find that. I want you to think about it again. Will this be a right triangle or not? We have a tangent, we have a radius, and the whole thing is still going to create a triangle. Because this whole thing is still a triangle. But we have two sides. So because it's still a triangle, it will create a right triangle. And we still have those pieces that we can use. Okay? So we know that right here, this is a right triangle. And we said again that BC was 12 and BM is 20. So my whole line is 20. Alright, so I don't know this side, which is going to be my x. So when I set up my problem, I'm going to have 12 squared plus x squared equals 20 squared. Again, we're using Pythagorean theorem. A squared plus b squared equals c squared. And your c is always your hypotenuse. Okay, your c is always your hypotenuse. So I want you to solve it, and I want you to find out what x is. Okay, so that you can find what CM is. Okay, so for number 6, number 6 says that we have find the length of XE. All right, so we want to find the length of XE, which is this whole line right here. Okay, find the length of XE if BM equals 25 and ZM is 20. Okay, so BM is this whole thing here, and that is supposed to measure 25, and ZM which is here, is going to measure 20. So think about how you would set that up to solve, and then I want you to solve number 6 independently. All right? Make sure you show me these notes when you are done. All right.